welcome to the deep dive. So, you sent us some pretty intense equations, really dense stuff, pulled from stochastic calculus functional analysis. But here's the thing, as we dug in, it started to look like, well, something else entirely, almost like a theoretical blueprint for, instantaneous travel, starship tech.
It is fascinating, isn't it, how these fields, stochastic calculus for predicting uncertainty, functional analysis for manipulating functions, how they could map onto something so, well, sci-fi sounding.
Exactly. So today we want to give you a kind of shortcut. How might these equations actually describe advanced propulsion, manipulating gravity, even defining the fuel for interstellar travel? Let's try and unpack this blueprint a bit. Okay, let's start with dSTdt. You called it the core velocity equation.
Yeah.
Looks like speed, but feels like more here, right? What's it really showing?
Right. dSTdt, that's the effective velocity. It's how fast the ship seems to move relative to normal, unwarped space. So it's not the ship breaking the light barrier in its local bubble. It's about changing the space around it, effectively shortening the journey.
Ah, okay. So you sidestep the speed limit by warping space itself.
Yeah.
Got it. Then there's that big integral term, chi sub phi phi ct. You called it the operational heart.
Yeah, that's a good way to put it. The variable inside, it represents all the parameters that define the warp field, the type of distortion, how intense it is, maybe the shape of a wormhole, and the C term, the composition operator. That's like the instruction manual. It tells the system how to use those parameters to actually transform space-time locally.
And you mentioned properties like isometry and unitary being key. They sound technical. What do they actually, guarantee?
They're crucial. They mean the transformation is efficient, no energy wasted, it's stable. And importantly, reversible. It preserves the ship's structure, ensures a safe trip, basically. It's like built-in safety standards in the math.
Efficient, stable, safe. Okay, that's huge. But what about that PST term, the conditional probability part? You flag that as really important.
Oh, it absolutely is. That PST term, it means the best way to manipulate spacetime right now. It dynamically changes. It depends on the ship's actual current state.
So it's not just following a preset plan.
Not at all. It suggests a really intelligent, adaptive system, constantly sensing, calculating, adjusting the field based on speed, energy, the environment. It has to sort of think on the fly. A huge computational task, probably.
Okay, so if we're not using rockets, what's the fuel? Still needs energy, right?
A lot of it. Immense amounts. But the fuel isn't something you burn and expel. It's the raw energy needed to, create and maintain that warp field or wormhole, the energy cost of bending space-time itself, and the efficiency of converting that energy. That's baked into the C operator properties and that dynamic PST part we talked about.
Right, energy conversion for space-time bending. And this all comes down to manipulating gravity, fundamentally. But there was an inequality mentioned too, a constraint.
Exactly. The whole thing is gravitational field manipulation. That inequality acts like a strict rule, an energy budget constraint. The system must obey it to keep the gravitational field stable and controlled.
So it's a safety mechanism.
Precisely. Keeps things from going haywire, prevents instabilities, field collapse, maybe even stops causality violations like accidental time travel paradoxes. It's critical for keeping it a ship and not, something catastrophic.
Okay, so let's pull this together for you. These equations, they're not just abstract math. They seem to lay out a really sophisticated, adaptive, and controlled way interstellar travel via space-time manipulation could potentially work.
Yeah, and it highlights how ideas from, say, financial math can be completely reframed for fundamental physics. Makes you wonder what else is out there. Maybe even ideas an advanced AI could derive. It's quite profound, really.
It really is mind-bending. So, a final thought for you to take away. If this gives even a hint of future propulsion, what other physics, what new possibilities might open up if we could truly master dynamically adapting space-time itself?